We're going to now look at actual equations. Is the function f of x equals 3 to the 3 plus x divided by x squared odd, even, or neither? All right. So to do this, I'm going to do this in two parts. First, I'm going to just check even. Is it even? So that means I need to take this function, the original one. I'm not going to write it down the whole the run. You see it right there, but I'm going to try to save some paper here. So take the opposite of it. So now I'm going to again replace that x with a negative x. Come down here, replace this x with negative x. Now simplify a little bit. What's negative x squared? Negative x squared is just, you can rewrite it as x squared. In other words, x times x is x squared. But if I think of this as -1, -1 times -1 is 1. Now, is that one? Well, the denominators are the same, but here I'm adding x and here subtract. No, these are not the same. So what we have at the result of this is that f of negative x does not equal f of x. And again, the way I'm showing it to you, that's the way I'm expecting you to show it to me. And then come to this conclusion and then say, hey, not even. Now what you're showing to you is that you can actually carry this algebraic steps and then come to the conclusion. And again, write it just like I'm writing. Line up these equal signs, make the changes, boom. That's it. It's that simple. Okay. Now, I failed to show that it was even. So now I'm going to go with the other one. It goes, well, what if I were to, so I'm going to back up here again, and I'm going to look at just, I know I've written over, you can't see it very well, but I did this part. So now I'm going to just do this part right here. Or if you want to use my function, what will happen is I did the first part here, and now I need to take the opposite of it and see if I come with the original. No, so I'm going to try my own first. So that's faster. So I've already done this. So now I'm going to do the following. What happens if I take that one I just finished and find the opposite of it? So notice how this works. I'm taking the opposite of everything you see here. But be careful. If you wanted to find the opposite of something like a number, for example, find me the opposite of 3/4, all I need to do is either write it like this, there it is, or give it to the numerator, or give it to the denominator. But you cannot give it to both. Either this says I give it to the whole thing, I give it to the numerator only, or the denominator. But the result is always the same. It's going to be -3/4. Okay. So now I have the decision to make. Where to give to this? Well, this is x squared. I mean, I can see they're matching right now, right? They're matching to the original. That's what I'm going to go. So I'm going to give it to the numerator. So I'm going to go to the numerator and I get, so, take the opposite of 3, this. And I can think of this as, a negative x for now. So the opposite of that is half. I hate sometimes doing this, but I'm trying to minimize my writing. So is that equal to the original f of x? Is this equal to f of x? And the answer is no. What we have concluded is that this is not equal to the original one, so not odd. So I went through both tests. Not odd, not even, so f of x. So the conclusion is f of x is neither even nor odd. Okay. Let's look at another one here. Is the function g of x odd, even, or neither? So let's kind of give this a whirl. So g of x. Okay, so I'm going to again leave it alone for the sake of space. So I'm going to first enter, see if it's even. Even. So do that. I enter negative x cubed plus 2 times negative x. And what do I get out of here? Okay, again, like before, negative x times negative x times negative x is negative x cubed. And here I'm going to get negative 2x. Okay. And I clearly see that looking back over here now, g of x does not equal negative g of x. It does not equal negative, sorry, g of negative x does not equal g of x. Great. So conclusion is not even. Now, is it odd? So again, using my little convention, I'm going to take this result and just take the opposite of it. So I'm going to come over here and take the opposite of the result I just got. So now when I do that, okay, I start to distribute this opposite of operation. The opposite of the opposite is just this, plus the opposite of negative 2 is positive 2. Now I look back up here and go, behold, this thing does equal g of x. It is. We have the opposite of g of the opposite of x is g of x. So this function, the function g of x, is odd. And what does that tell me? That all of a sudden, if I were to graph of it, whatever this looks like, I'm just making, should I? No. It looks something. Let's just say, for argument's sake, it looks like this, just for fun. That means on the other side, imagine these points could flip across, down, flip across, down. All of a sudden, it would make some kind of, so in fact, what you could do, you could find these explanations. What's going to happen is imagine rotating 180 degrees on itself. What kind of picture would you get? Let's see. Let's see if I can mentally do this. Is that right? Seems right. Something like that. So again, if I were to flip it, it would just land on itself again. But flip it in what way? Okay, so I go across and down, across and down. Yeah, I did an okay job, but something like that. So you can rotate it 180 degrees like this, and all of a sudden you get the same looking picture. I did okay. It's a little harder to see when it's odd. So even, flip across this x-axis and bend this across this axis. That's even. The other one is rotated. Imagine this is the center of some wheel and you rotate it 180 only, and it should flop back on itself.